5. Right, so now we're going to deal with 10 to the power 4 and 10 to the power 5. So now here, what is the technique that we need to use? So here we have an even power, which is 4. So we need to get our squares. Okay, so for sine and cos, if we had x to the power 4, we used our exponent law and we needed to get that square by using the law of power raised to a higher power. 2 times 2 will give you 4. That's for sine and cos. Now for tan and cos, you need to get that square so we can use our square identity, but in a different way. So instead of writing x squared all squared, we need to write down x squared multiplied by x squared. It will still give you x to the power 4. Right, so you need to remember the difference for sine cos compared to tan and cos. So we got tan to the power 4. So that will be written as tan squared times tan squared. Right, so we applied the law, exponent law. Now we use our square identity. What's a square identity that involves tan squared? 1 plus tan squared of bx is equal to what? Sec squared of bx. So now what you will do is you will apply your square identity to one factor only. There's 2 factors there. Tan squared multiplied by tan squared. But we apply it to one factor only. You can choose any one. Okay. So now I'm going to choose the second one. So we got tan squared. So I'm going to apply my square identity here. That's tan squared. The square identity is 1 plus tan squared is equal to sec squared. This is not 1 plus tan squared. It's just tan squared. So how can we replace tan squared? All you do is you look at your formula sheet and you manipulate the equation. What will tan squared be? It's going to be sec squared plus 1 or minus 1? It will be minus 1. Okay. Now, after you do this, you are going to multiply out. What do I mean by multiply out? So what do we have here? We have k squared, let's call tan k, let's call sec m. So we got k squared, then we got m squared minus 1. So we're going to remove the brackets, multiply out. So this will equal to k squared times m squared, and then k squared times minus 1 is minus k squared. Obviously we're going to include the integration sign for both. So now let's do it here. So I'm going to multiply just like what I did there. So that will be tan squared times sec squared. Here's my integration sign in dx, don't forget that. Then tan squared times minus 1, which is minus 1 tan squared. So now I have tan squared alone. We go back to our n5. When we just had tan squared, what did we do? We applied our square identity. So tan squared, you got your square identity. Tan squared can be rewritten as, that's going to be sec squared minus 1. Here, what do we have here? We have multiplication. Can you see that? We got multiplication. What type is it? It's type A. How do you know it's type A? Because you have f of x, f prime x. Which is f of x? It's tan. Not tan squared, but just tan. Because the derivative of tan is sec squared. So this is type A. You always let u equal to f of x. This is type A. So it's type A again. Right, so here, let me just write it down here. So now, you're going to let u equal to, for that, let u equal to tan of x over 6. So, du over dx, what is the derivative of tan? It's going to be sec squared x over 6 times the derivative of x over 6, which is 1 over 6. So therefore, dx will equal to du all divided by 1 over 6 sec squared x over 6. So the substitution only applies to the first term here because it's type A. Here there is no substitution here. So I'm going to replace tan with, I will replace tan with u. So this will be u squared times sec squared of x over 6. What about dx? Dx is replaced with du divided by 1 over 6 sec squared of x over 6. Right, so here you can just leave this as it is for now. We're going to integrate it straight from the formula sheets. So let's see what happens now. The exact derivative cancels here. Can you all see that? Sec squared and sec squared will cancel. So I got 1 divided by 1 over 6, which will be 6. That's u squared du. Okay. So now I can integrate everything. Here, this is du. I'm integrating with respect to u. Here, this is dx. It has nothing to do with the u substitution. So this will be 6. I can integrate u squared, which will be u to the power 2 plus 1, which is 3 over 3, minus, now I need to integrate sec squared. How do I integrate sec squared? Remember, integration is a reverse process. Think about, what did you differentiate to get sec squared? 10. That means if you integrate sec squared, you get 10. Right, so the derivative of tan is sec squared. That means when you integrate sec squared, it will be 10. So the integral of sec squared will be tan x over 6, all divided by what? By 1 over 6. Here you are integrating 1 with respect to x. What will it be? Just x. You're done. All integration is done. So now you put down plus c. Let's just substitute back there. We got 6 divided by 3 there, which is, so that's 2 u cubed. What was u? U was 10. So that will be 10 cubed of x over 6, then you got minus, you got tan x divided by 1 over 6, which is 6 tan x over 6 minus x plus c. You're done. If you want to, you can just multiply out here, but it's not necessary. If you want to multiply out there, that will be minus 6 tan x over 6 Negative and negative there. Positive x plus sec. So this is a bit different compared to sine and cos. But it still involves square identities.